So thanks for the introduction. I'm Marc. This is Ryan. I'm a principal engineer at Flipdish. Ryan's a senior software engineer. And at Flipdish, we build products for restaurants. So we build, if you look across here, we've got apps for ordering, iOS, Android apps, websites, kiosks, point-of-sale systems, and then kitchen display screens and other technology in the kitchen. So we launched in 2016. We've handled 50 million orders to date, and we process more than 1 million orders every month. So online takeaway orders on apps, orders in store, things like that. So we're going to talk today about the back end. So I'll give you a quick intro of what our back end does. We've got orders coming in. So orders might come in from our apps, our websites, over the phone, in person. We also get orders from third parties like Google, Just Eat, Uber. That's all coming into the system. We take those orders, we send them out to 5,000 devices we have in kitchens and in restaurants throughout the UK and Ireland. And we also send orders out to other partners, so to delivery drivers, to like Uber, Deliveroo, those sort of companies. We also send orders outwards to third-party point-of-sale systems. So you might use Flipdish online ordering, but not our point-of-sale. So we can still send your orders into your own point-of-sale. That's sort of the flow we're talking about today. So we're going to talk about the main characters today. We have two monoliths to talk about. The first is Zeus, and the second is our RMS, our restaurant management system. So Zeus is a C# ASP.NET app. It was written in 2014, and it was written using a very modern tech stack for 2014. So thinking about what Simon was talking about there with maps, our tech stack started over on this side. It was a sort of commoditized tech stack in 2014. It's pretty standard. It uses an Azure App Service, SQL database, Redis, table storage, and a service bus queue that we'll come back to later. So I was asking around within Flipdish, what does Zeus do? How can I tell it? And my colleague Adam said it's easier to talk about the things Zeus doesn't do. It's a shorter list. So we can answer telephone calls using Twilio. It's a URL shortener. It can build websites. It hosts websites for thousands of restaurants, custom domains. It can build QR codes if you want to order at the table, scan the QR code for the menu, we do that. It can build and deploy iOS apps and submit them to the App Store. It does everything. And it's the online ordering system. RMS then is the point of sale. So in 2022, we acquired a company. They have a point of sale system. So it's a front of house, your cash register, and then the screens and printers in the kitchen. It's a very similar tech stack to Zeus, which is something we really liked about the company. So it's Node.js rather than C#, but apart from that, it runs on Azure in an app service. It's a SQL database, Redis, table storage, and a service bus queue again. So the same shape, which I really like. It's a modern, well-structured code base, not like Zeus, but it's still one monolithic app. It's built by a small team. They ship it as a single artifact into production. And we see in that what we saw in Zeus back in 2014, 2016 through launch. And we want to protect it. So the most important question a software engineer can ask, what problem are you trying to solve? This is RAM. In 2022, we had to post RAM out to all of our developers and a set of special screwdrivers to open up our laptops because Zeus wouldn't build on the laptops anymore. We had to double the RAM everyone had, which was a signal something was wrong. So the problem statement I wrote was the Zeus code, the stack, the tests, and the deployment slow our delivery. And it's slowing delivery for our teams that work inside Zeus. It also slows delivery for teams that are building outside of Zeus. So the code, writing code in Zeus is slow. So opening the editor takes minutes. The initial build takes minutes. You save a file to make a one-line change. It's about a minute before you'll see your syntax errors. Running the tests, 2 or 3 minutes to start running the tests. Restarting IIS, another couple of minutes. The whole process is slow. So things that should be instant take minutes. So we get this sort of scenario where the time to open the editor, for let's say, increases linearly with the number of files. The stack, the technology stack is obsolete. So Simon mentioned earlier that things change. Our stack started over here, but it's now a custom stack. It's way down here. So our engineers are spending time supporting this old version of .NET, this old version of ASP.NET, which the modern versions of those systems don't have problems. So one example, we've got some authorization code, and it needs to hit the database and check if a user has the right permissions. It should be using async await. It can't because the ASP.NET version we're pinned on only has synchronous support there. So we've got a known performance issue, bottleneck, it's blocking threads when requests come in. And fixing it is requiring clever engineering for us, where if we were on the later ASP.NET, it just wouldn't be a problem. Tests, so testing Zeus is slow. We have a lot of tests, they're slow to run. Unit testing coverage is low, and the code isn't written in a way that is amenable to writing good tests. So because unit testing is slow, we end up writing integration tests to cover the main paths. Integration tests are slower and they're flaky. As we end up writing too many integration tests, we over-rely on them. And we get this sort of relationship where we get a bigger test suite, number of tests increases, the time to run the tests increases. And if we've got integration tests which are inherently flaky, the more integration tests you have, the more chance you have of a failed build due to a flaky test. Deploying is slow. The pipeline takes an hour. So to build your pull request and get a green build, it's about an hour, and then the deployment after that, another hour. We limit our release window to 10 a.m. to 4 p.m. We don't want to release after 4 p.m. because it's dinner time. And because Zeus is a monolith, all systems are together. So even if you're changing something peripheral, there's a big risk you could break the central ordering flow. So we don't release after 4 p.m. So that gives us at max 5 deploys per day, typically way less than that. And the big problem as well with this is after lunch. If you write code after lunch, it's an hour to build your PR, an hour to deploy. You're not going to get it out that day. So any change you make after lunch, best case, it's going out the next day. So slow. And these problems compound. So because it's slow to write code, it's slow to refactor. Deploying your refactors is slow. It's going to take a day to get it out. So the whole process, everything feeds into itself, into the next stage, slowing everything down. So we end up with this kind of graph. So the more and more features we add to Zeus, we get this exponential growth in the time to ship a change. It just gets slower and slower. And we've seen this growth from 2016 that launched through to today. Just things get slower and slower and slower. So the most important question a software engineer can ask is, what problem are you trying to solve? We have two systems. We've got an online ordering system. This is Zeus that we started in 2016, and the point of sale that we acquired. And there's an overlap in features between the two. So you can see we've got user accounts duplicated, audit logging, opening hours, a bunch of features. We thought it was quite small until we dug in and we found there's a lot of overlap between the two. But how is that a problem in real terms? So our clients have a problem with that. We've got 2 web portals they need to log into, 2 different usernames, 2 different passwords for 2 systems. We've got settings in the 2 that are duplicated. So our clients and our staff need to make sure the settings are in sync between the 2 for the system to work. And then our customers in store see 2 different experiences. So if you're ordering online, the menu might be different to the menu you get in store on a kiosk because it's running on 2 different systems that might not be in sync. So now I'm going to hand over to Ryan, who's going to talk about what his team was doing while we were all toiling away on Zeus, and their team were having more fun.
Thank you very much, Mark. So I'm going to talk about the eco and payments team, which is the team that I joined. I'm going to bring you back to the point in 2021, which is when this team was formed. The team joined fully remotely, engineers were working remotely, and it was just post-COVID. And Mark has talked about our monolith and how difficult it is. And trying to onboard brand new engineers remotely into this system has proved to be very difficult. And our team was tasked with managing our existing integrations and also build some new ones. And these integrations were with the likes of some third-party delivery companies like Uber and Deliveroo, but also some point-of-sale companies. So what we did, we got the opportunity to build outside of the monolith and get a sense of what serverless could actually be like. We got the opportunity to do the Greenfield project, and we were using Azure functions. And we've seen a lot of the problems with trying to write unit tests inside of the monolith. It was very difficult with all these existing integrations in there, and that was something that we wanted to solve. And I'm happy to say when we moved over out of the monolith, our new integrations outside of there, we've achieved around 90% unit test coverage in the majority of our integrations. And this quote came from management throughout the years. So we scaled up massively in 2021. We were hiring rapidly. We were growing developers. But then we've also had some layoffs and some restructures. And this quote came from the management: "Keep the team together because they are delivering." And I think this was important, that the business recognized that our team working outside of the monolith were delivering value, and we didn't want to break them up. So I want to introduce you a little bit more into this project. So as I mentioned, we were using Azure functions. So we got separate functions for each one of our integrations, and that meant that we had separate deployment pipelines for each one of our integrations. So rather than trying to deploy the monolith and everything together, we could deploy each single integration one by one. And that meant we only had to run the unit tests and integration tests for that specific integration. And ultimately, this gave us a lot of confidence. So we didn't have any release window compared to working in the monolith. And our upgrades were done incrementally. I'm not sure why there's a gap there, but in there that should say that we started off with .NET 5 on Windows and then migrated to Linux very shortly after. And Marc alluded to how difficult the monolith was to upgrade. But since we had separate integrations, we were able to do each one of these integrations individually. We were able to plan them into different sprints and do them over time rather than one big batch all at once. And then we were able to stay up to date with .NET being released. So we were able to go to .NET 6 and all the way to .NET 8 as well. It's important to note, though, that the Azure consumption plan that Azure had didn't meet all our requirements. There was some private networking that we needed to have in place that they simply did not offer. There's also a bit missing at the bottom that I'll talk about as well. So we were talking about using the premium plan in Azure Functions rather than the consumption plan. So this meant that we had to pay for a single server, have the compute always there. And the problem with that was, as we added more and more integrations, we ran into issues with the amount of memory that we were using, because the more integrations, the more memory, and even when they were idle, not even being actively used. So we ended up moving away from that and using container apps in Azure. So a little bit of their server offering, but what we ended up doing is wrapping Azure functions inside of Docker, so kind of going away from the native Azure functions. But over the years, they've come out with some new features for Azure Functions, and they've actually come out with something called the Flex Consumption Plan, and that's solved a lot of our problems with the Azure Consumption Plan that we originally were looking at, so we're planning to move back to that. So we'll end with today's environment. So we've got 7 different integrations inside of this environment. We've got 3 shared services across that, and we're doing about 1 million requests per month, just purely in this environment, and not even talking about the monolith. And in peak, we're doing about 7 requests per second. And I think it's one important thing to note here is that we've had no customer complaints when it comes to reliability. So these integrations have been running very smoothly, and any bug fixes we can do, we can get them out very quickly. So our customers have been very, very happy with this. I'm going to pass you back to Marc.
Thanks, Ryan. So the most important question a software engineer can ask is, what problem are you trying to solve? We're going back to this problem of 2 systems and that overlap between them. So we have 2 loyalty systems at Flipdish we had. So you might order 3 times online, you get 3 stars on your loyalty card out of 5. Then you order twice over the phone, which goes into the other system. You get 2 stamps on a different loyalty card in a different loyalty system, and you get no free meal. So that's the problem. This was a burn the ships moment at Flipdish. We decided we're not going to try and fix Zeus. So we've had many projects over the years where we've upgraded things, we've sped things up, we've modularized the code base, but it's slow going. And at the same time, we saw Ryan's team shipping things really quickly and fast outside the monolith, so they showed us the direction we needed to move. We're also not going to pile more features into the RMS because we see the risk of building a second big monolith, so we knew we had to protect it and not just dump more stuff into the RMS. So we're going to build a new tech stack, and we wanted specifically to choose the best tech stack that a startup in 2024 would have chosen, because that's going to be who's competing with us. So we needed our engineers on the best stack. And we also needed to solve the Zeus problems and give our teams the confidence and autonomy to ship. So we went all in on serverless. So the project, we called it Loyalty 360. And the idea was a new greenfield implementation of loyalty that would let us take all the loyalty code out of Zeus, take all the loyalty code out of RMS, and just have one service that deals with it. It was a really small team, so we just got 3 developers, a product manager, and a product designer, and a short timeline. We had one critical client that was very keen for this. We agreed a 2-month timeline where we're going to ship the feature for this one client in 2 months. We had a lot of support internally, so our CTO was helping drive the project and giving the team the clearance they needed, and we also had an SRE and an infrastructure expert in a support role if we need any help getting things set up. And we were going with serverless first, so the entire stack running on AWS Lambda, an event-driven architecture with EventBridge, all storage is going to be serverless with DynamoDB, and all infrastructure defined with infrastructure as code using CDK, and no ClickOps allowed anywhere. At the start, we scaffolded up the project using Node.js, TypeScript, and Lambdas, and CDK for deploying. It took us 2-3 days to get a nice little prototype up and running, but a colleague suggested we look at SST, which we've been really happy with. So SST is a framework that lets you define your app and your infrastructure all in one package together. And we were able to rebuild the stack that we'd spent a couple of days building beforehand in SST in 2 hours. And we've been really happy with our decision to use SST. So how can we build outside the monolith? Ryan's team had showed us the way, but there was still a couple of problems we needed to solve. So our authorization system was stuck inside Zeus. We had no access to authorization outside. And we had domain events stuck inside the system. So we needed to stamp loyalty cards. So Zeus needed to tell us when an order was created. The point of sale needed to tell us when a sale was completed. And these were stuck in the service bus queues that were used as internal work queues in those systems. And we had no access to those events. So for authorization, we added a new endpoint to Zeus. It lets us post a JWT token, validate the token, and get back a user's permissions. So adding one little fix to Zeus, and then wrapping that in an AWS Lambda authorizer. That let us insulate our teams from the details. So the teams don't need to know that Zeus is doing this authorization. We can wrap it up and just give them a Lambda that does it. For getting the events out, we came up with an amazing serverless solution. So from the service bus, we're going to trigger an Azure function. That's going to make a HTTP call to an AWS Lambda. That Lambda is going to put the event into EventBridge, and we shared this project or ideas internally, and we're met with a bunch of people saying, WTF. So we scrapped the idea, and instead we just took a 10-line C# function in Zeus to send events to EventBridge. It was 10 lines of code, and it works. And the reason I wanted to talk about these examples is there were small tactical changes to Zeus to let the team move on with the strategy of getting outside Zeus. So remember, we've agreed we're not fixing Zeus. So we go in tactically, we make a change, and we move on. This is a very high-level view of the architecture we came up with. So on the left, we've got the services in Azure running away. We've got Zeus. We've got the point of sale. They publish to EventBridge. And then from EventBridge, we trigger our Lambda on the right here, Loyalty 360. Crucially, Loyalty 360 knows nothing about the other systems, and the other systems know nothing about loyalty. It's all driven by events. So now I'm going to talk about some of the results we had with the project. Writing code in Zeus was slow. SST gives us hot reloading of code. So when you start SST, you get a live Lambda running. It's running in AWS Live. When you save the code in your editor, the Lambda updates instantly. So it's not that we've sped people up, that it used to take a minute and now it takes 10 seconds. It's instant now. So the change has been transformative. SST gives us hot reloading of infrastructure as well. So if you can imagine back in the Zeus days, if I wanted to add a new SQL database, that would be opening a Jira tickets on the platform team's backlog, getting in touch with them before their sprint planning, hoping they pick up my ticket, hope to get my database, maybe have some meetings to get requirements. With SST, I was building the system and I needed a new DynamoDB table. So what I was able to do was go into the infrastructure file, define the new table, save the file, and in the terminal, it immediately starts provisioning the new table. It's live within seconds. So again, it's not that we've cut the time to get new infrastructure from a week to a day. It's gone from a week to being instant. Testing. So writing tests in Zeus was slow. Writing tests now, it's greenfield project, so we've been able to start test first. So everything is tested. We can run the tests now in watch mode. So as you're saving your file, your tests are running. So again, with Zeus, we had this couple of minutes every time you wanted to run a test. Now it's instant, it's live. SST allows us to test infrastructure. So it's the infrastructure's code, it's CDK, it's TypeScript. So we can write tests for the infrastructure, which we could never do in Zeus. The deployments are fast, so they take 3 minutes to get something live. We can now ship whenever we're comfortable. No more release windows for our teams because we've split the system into services. So there's really reduced risk that a change I make to loyalty is going to break the online ordering flow, so I can release whenever I want. And then teams won't block each other's pipelines. So with Zeus, the flaky tests, if one team introduces a flaky test, the pipeline's broken, no one's shipping that day until that team can fix their test. And iterating on those flaky tests, again, it's an hour, it's an hour, it's an hour. Whereas now, teams have their own repos, their own pipelines. They can just ship when they want. And compounding. So the Zeus problems all negatively impacted each other. Every problem made the next problem worse. With the new system, it's a positive feedback loop. Every change we make makes the next step faster and the next step faster. So we had this graph earlier. So every new feature we added to the monolith had this exponential growth in the time it takes to ship a change. So we've cut it now like this. So crucially, we still have exponential growth. Every feature we add to a service makes that service slower, but the number of features in each service is slower. So that exponential graph never gets that chance to take off because we've constrained it with services. So now I'm going to hand back. Oh no, I'm going to keep talking about what went well. So one repo with SST, but I guess just Git in general, we've got our services in one repo. So all the code, all the infrastructure in the repo. We've got the GitHub Actions for deploying is all in the repo. Secrets we can manage with GitHub secrets. That means we can use our existing Okta and permission control system with teams to give them access to their secrets. Everything the team needs to ship is in that one repo. And it's been wonderful. AWS accounts, we use them kind of like a bulkhead. So every team has their own AWS account. We manage this centrally. We have a governance repo with Terraform where teams can make a pull request if they need to add a teammate or give themselves a new permission on their account. And once they merge that pull request, their AWS account updates. So each team has their own AWS account, which means it's nearly impossible for any one team to negatively impact another team. We just don't have physical access to each other's resources. We get isolated observability. So within your own AWS account, it's the only thing in your team's CloudWatch metrics are your team's metrics. With costs, the only cost you have in your AWS account are your own costs. We pull this through to Datadog. We have everything tagged by the team and also by the AWS account. So everything in Datadog is partitioned by team with this method. Really recommend it. Now I'm going to hand over to Ryan, who's going to talk about things that haven't gone so well for us.
You, Marc. So I think while overall we've talked about serverless and how it's been a net positive for Flipdish, but at the same time there have been a few things that we have hit that haven't worked so well. And the first thing here was when we were using SST and we're configuring lots of these new resources, we ended up hitting some limits within AWS due to how we were configuring our resources. And sadly, we have lost a few days to this, so it definitely has been a learning curve using a lot of these new features. Also with Dynamo, this is the database that we have chosen. And while it's great and it has some great performance to it, it is also quite rigid. So we tried to add a new feature to be able to search for some records, but unfortunately, it was actually case sensitive. So trying to implement this new search feature was actually quite difficult and took us longer than we had expected. Also events. Events are difficult, and our topology here is actually quite complex as well. We'd written the code to actually publish our events in our service. We had code to receive events, but they weren't going out. We weren't receiving any, and it's just very difficult to troubleshoot. And what we didn't realize was there was actually another repo that we needed to update, that we needed to configure all the rules globally for all our services. And also data migration. I'm sure we've all tried to do this, and this thing is freaking hard. And our teams have had some different strategies trying to do this. We've had some lazy migrations. We've talked to going to Snowflake and reading data from there, or even as far as going to the production database and reading directly from there and in terms of a read replica. And ultimately, we haven't found a solution that all our teams are happy with, and we're still trying to look for something that fits our needs. And to conclude and paint a picture of today, we've talked about our golden path, but it's one thing saying that one or two teams have actually started to adopt this and we're getting a lot of value out of it. But it's another thing to say that all teams in general have deployed at least one service in our golden path. And we're happy to say that every single one of our teams have uptake this and have deployed at least one service. Autonomy has been unlocked. The monolith is shrinking. Marc has talked about Loyalty 360 and being able to delete code out of the two monoliths. And that's not the only feature. We've done it with our receipt service and also some audit logs as well. And ultimately, we're all learning in AWS serverless. We're all pushing towards that one goal, and that means that management and our platform teams are there and available to help us. And as Marc talked to in terms of getting our infrastructure set up in our monolith, if we wanted to add a new SQL database, it meant going into sprints, planning with other teams. But that ownership is now shifted directly onto the teams, and things have been a lot faster. We've reduced the bottlenecks, independent delivery of all our separate pipelines. We're not tripping over each other anymore. And I think this truly opens up end-to-end ownership for our teams. Today, we haven't even talked about the front end, but we have the ability to bring that into these services as well and deploy our micro front ends from inside these services as well, giving the teams full stack ability in these services. But obviously, we've talked all about this technology, but our clients don't really care what we're doing. If it's serverless, if it's a monolith, they just want to get value out of our system. So the main question is, are we shipping value for our clients? And I'm happy to say, here's a feature for our SMS campaigns. The purple is where we did some internal testing, and we can see a gradual uptake in people engaging with this feature. Then we did a big marketing release, and we got a big uptake engagement on that day. And ever since, we've got some steady growth for this feature. And for Loyalty 360 that Marc's been talking about, we shipped that for all new clients and the problematic client that we needed to release this for. And then we needed to do it for all our clients. And you can see that massive uptake here. So all clients were getting their stamps earned, they were redeeming them, and that was really great to see. And it was a moment when we could start actually deleting all the code from the monolith. And that is us. Thank you very much for listening.